Welcome to Math TV with Professor V. I have another integral for everybody. And since it's probably that time in the semester where students are learning trig sub in Calc 2, I figured it was the way to go. So here we have indefinite integral 1 over square root of x squared plus 2x plus 5 dx. I'll give you a second if you want to pause the video and try it on your own. I already said it's trig sub time, but it may not be obvious which trig substitution to use. So notice in the denominator, we have a quadratic expression underneath the radical, and it does not factor. No. So what do we do in this scenario? We complete the square for x squared plus 2x, and then go ahead and make an appropriate trig sub. And how do I know to do this? Just because I've done hundreds of others that are just like this. This is the way to go when you have some prime quadratic expression, okay? So you take x squared plus 2x, and then divide the coefficient in front of x by 2, and then square it. So that would be a 1. That gives me a perfect square trinomial. And I'm noticing here we have a 5, so I'm just going to borrow 1 from the 5 and break it up. So then now it's 1 plus 4. Sound good? And then I can factor this into the quantity x plus 1 squared. And then whoever wrote this problem loved us and they were looking out because 4 is also a perfect square. That's 2 squared. So typically when you have your variable expression squared plus some constant squared, we're going to use tangent for our substitution. And so how would you choose it? Well, all of this x plus 1 is going to equal a, which is 2 tan theta. All right? And then go ahead, differentiate both sides now. So dx, derivative of x is just 1 dx. Derivative of 1 on the left-hand side is 0. So that's done. And then that equals 2 secant squared theta d theta. And we should be ready now to rewrite our integral all in terms of theta. Okay? So let's give it a go. I'm going to rewrite everything. I have 1 over, and then remember, this is basically underneath the radical, right? We have x plus 1 squared plus 4, 2 squared. So x plus 1 squared is going to be 2 tangent theta quantity squared. And this is all under the radical. So 2 tan theta squared plus 4, and then dx is right here. So times 2 secant squared theta d theta. Very nice. Let's see how things simplify. Radical. 2 tan theta quantity squared would be 4 tan squared theta plus 4. And then I have 2 secant squared theta d theta. And then the whole point of doing the trig sub is so that you can clean up and use a Pythagorean identity to simplify this quantity. So if I take out the 4, then I have tan squared theta plus 1. And that's all sitting underneath the radical. This is 4 times tan squared theta plus 1 is equal to secant squared theta. Since that's sitting underneath a radical, yes, this is going to simplify to 2 absolute value of secant theta. And you don't have to fuss too much with the absolute value. When we do trig sub, we restrict the values of theta so that we don't have to worry about splitting up our integral or keeping the absolute value. So you can drop them. But I just want to make it clear that we're not dropping them out of carelessness. We're dropping them by design. Okay, so enough said. We have now 2 secant squared theta d theta over, and then how did my denominator simplify? Right here. I'm just going to write 2 secant theta though, okay? Good, things are looking so lovely. I'm thrilled. The 2's cancel, a secant theta cancels. This is a beautiful little integral. Secant theta, d theta. Do you know antiderivative of secant theta? You should. That's one to put to memory. The way to derive it is you multiply numerator and denominator by secant theta plus tan theta and you make a u sub. It's not very intuitive. So for that reason, I would say, you know what? Go ahead, just memorize it. Excuse me for needing to add a page here. So what is it? It's natural log, absolute value, secant theta plus tan theta, and then I'm going to put plus C1. Why C1? Because at the very end, I'm going to rewrite a few things to clean up. I can see into the future. And so I'm saving plus C for the very end. You'll see in a second. So right now my antiderivative is in terms of theta. I need to get back to x's, right? Originally the integral was in terms of x. So how do we do that? Well, look at the substitution that we made right here. X plus 1 equals 2 tan theta. So if x plus 1 is 2 tangent theta, that means x plus 1 divided by 2 is tangent theta. So you're going to draw yourself a little right triangle. Put theta somewhere. So tangent theta is the ratio of the opposite over adjacent side. And then using the Pythagorean theorem, I can find the hypotenuse. It's going to be quantity x plus 1 squared plus 2 squared, and then take the square root of all of that. So that would be x squared plus 2x plus 5 once I clean up. And you guys, it's no surprise, didn't we just see x squared plus 2x plus 5 when we first started the problem? Why, certainly. Do you see it right there? Right here. So usually that expression will pop back up somewhere in the triangle. Some instructors have you draw the triangle first so you can see it. Whatever, it's all the same. Okay, now let's go ahead, use the triangle so we can rewrite everything in terms of x. So secant theta, that's going to be the ratio of hypotenuse over adjacent side. So that's square root x squared plus 2x plus 5 over adjacent side is 2 plus now tangent theta over here, that's going to be opposite over adjacent. We actually already had it right here. Here's tan theta, x plus 1 over 2. All right, plus C1. And then here is a common little simplification technique that you're going to need to finish off the problem. You see how both terms in the argument of the natural log have the same denominator? So I'm going to rewrite this as ln, absolute value, and then we have here radical x squared plus 2x plus 5 plus x plus 1 all over 2 plus C1. And then using our properties of logarithms, all right, I can go ahead and rewrite this as natural log, absolute value, radical x squared plus 2x plus 5 plus x plus 1 minus natural log of 2 plus C1. And you might say, Professor V, I don't know what you just did. Let me remind you, okay, recall, if you have natural log of A divided by B, you can write that as natural log of A minus natural log of B. That's not just for natural logs, but since we're dealing with natural logs, I wrote it as such. So A divided by B is ln of A minus ln of B. All of this was A, this was B. So here's ln of A minus ln of B. Can you see? Well, why do we do that? Well, let me tell you. Negative natural log of 2 is just a constant. So I'm just going to lump all these together and call them C, my new constant, so that my final answer is the most simplified and beautiful it can possibly be. So we have ln radical x squared plus 2x plus 5 plus x plus 1. And then I go plus C, where, tell the people, who is this C? C equals C1 minus natural log of 2. And voila. That is a 100%, 10 out of 10, perfect answer. If only I could box it. There we go. And show off my lovely work. So I hope you enjoyed. I hope you could follow along. And most importantly, I hope you'll be able to recreate this solution for yourself on future exams or whatnot. Give the video a thumbs up, comment down below, let me know what you're up to this weekend. How did you enjoy this video? I am working on making more things, don't you worry, but I am currently overwhelmed with grading. What else is new? Everyone just took an exam last week, so it is what it is. But thank you all for your support. Subscribe if you haven't already. Give this video a thumbs up. You can also follow me on Instagram and TikTok, Math TV with Professor V. I love you all. I'll be back soon. Bye.